So addition polymerization, when we form a long chain compound by small molecules, we call that as a polymerization. And because we have only one product, that's why it is called addition polymerization. Now, what happened in addition polymerization? Example, you have this structure CH2 double bond CH, then CH2 CH3. What is the name of this compound? Name of this compound. 4 carbon, and the double bond is between the first two, so it is butene. And is it a monomer or a polymer? So it will be a monomer, a small molecule, it's a monomer. The molecular formula, the actual number of atoms, it contained 4 carbon and it contained 8 hydrogen. And what is the empirical formula? It will be CH2, the simplest way. All alkenes have empirical formula CH2. Now I want to draw a polymer, then first stage, the first step to draw a polymer, I will draw the same butene, but I will rearrange the structure. So if I rearrange the structure like C double bonded with C, hydrogen, so one hydrogen up, one hydrogen down. Then a carbon with hydrogen, so up or down, it's up to you. Because look, these are the 2 carbon which are having a double bond. So first carbon have 2 hydrogen, second carbon have 1 hydrogen. It is up to you. You can make up or you can make down. The next carbon is having CH2 and CH3. Hydrogen is there, and then so I can make it up CH2, CH3. Is it clear? So first what we did, we rearranged the structure. So the 2 carbon which are having a double bond, first carbon is having 2 hydrogen, that's why up, one down. The second carbon is having 1 hydrogen. So if one is up, like it can be up or down, it's up to you. And next to that is a carbon chain which is having CH2 and CH3. So we made CH2 and CH3. So this is also butene, but we rearrange the structure. If I want to draw a polymer, so I will draw the same structure, and I have n molecules, like I have many molecules of butene. And if I want to draw a polymer, even it is acceptable if I write only one time, I will draw the same structure, but without a double bond. And put a bracket and n. Even I did not repeat many times, I just put n, that is also correct. But sometime in the question they say draw 2 repeat units or 3 repeat unit. In that case, you cannot just draw one time, you have to repeat twice or thrice according to the question. So this is actually an equation for polymerization, like monomer from a polymer. So we have n molecule of butene. It will form polybutene. Is it clear? The polymerization of alkenes. And the empirical formula of monomer, which is CH2, is same as empirical formula of, because when I take the simplest ratio between the atoms present in the structure, I will get the same empirical formula. Molecular formula, definitely, it will be different. For polybutene, it will have many carbon atoms, but the empirical formula, which shows the simplest ratio between the atoms present in the structure, is same for both polymer and monomer. So another example, if I have but-2-ene. But-2-ene means there are 4 carbon atoms, and between the second and the third, there's a double bond. And this structure is given like CH3, CH, CH, CH3. First thing, if I want to draw a polymer, what I have to do, the first step is rearrange the structure. So to rearrange the structure, it should appear like letter H. So C double bonded with C and make one bond up, one down, and same thing for other carbon. Now, these two carbon-carbon double bond, so these are the carbon-carbon double bond. How many hydrogen are there for the left-hand side carbon? 1. So if it is having 1 hydrogen, so it's up to you. You can make up or down. It will not make any difference. So it can be up or it can be down. Then how many carbons are next to that is CH3. So the other will be CH3. The right hand side carbon is having 1 hydrogen. It is up to you. You can make up or you can make it down. And then next is CH3. So this is a monomer. This is butene. The monomer is but-2-ene. Now to draw a polymer, what we will do, we will draw the same structure. If we have n molecules of, I'm not drawing all of them, we have n molecules of but-2-ene. So it will form a polymer. So draw the same structure without a double bond. And link them with each other. Put N. The polymer it will form, it is polybut-2-ene. Is it clear how to draw the structure of the polymer? How many times you should draw a structure? You can even draw 1 time, you can draw twice, you can draw thrice, depending on the question. If there is no limitation, or in the question they did not specify that draw 2 units or 3 units, then it's up to you. Even you can draw 1 time and put N. But if it is mentioned in the question that draw 2 units, so you should draw 2 units. Then the next topic is alcohols. Before going to alcohol, the polymers of the isomers of alkenes. What are the isomers of the term isomer means when compound have same molecular formula. But different structures, we call them as isomers. So compounds having a same molecular formula, but they have different structure, we call them as isomer. How to draw isomers of So how to draw isomers of alkene? So there are 2 ways to draw isomers of alkene. Number 1, just change the position of double bond. That is one way of changing the structure. The second way, draw the cyclic alkane. So example, I have a compound which is butene, CH2, double bond CH, then CH2, CH3. So this is butene. I want to draw the isomers of butene. So what I can do, I can change the position of double bond. The double bond is between the first and second carbon. I can make with the second, like second and third. So this will be CH2, CH, CH, and CH3. What is the name of this compound? When I change the position of the double bond, so it will become but-2-ene. Or what I can do, I can draw a cyclic alkane. If I draw a cyclic alkane, I will draw 4 carbon in a loop, and each will have 2 hydrogens. So that will be cyclobutane. Why we call them as isomer? Because the condition, the definition, they have same molecular formula, different structure. What is the molecular formula of but-2-ene? It is C4H8. What is the molecular formula of cyclobutane? That is also C4H8. So molecular formula is same for both, but their structures are different. Even though there is no double bond in cyclobutane. Cyclobutane is having a single bond. But why still it is known as a polymer, it is known as the isomer of butene? Because it has the same molecular formula. So when two compounds have the same molecular formula, but they have different structure, even the type of the bond is different, even the number of bonds are different, but they have the same different structure and same formula, we call them as isomers. So whenever you're drawing the isomers of alkene, what you will do, you will change the position of the double bond. This is one way, or you can draw a cyclic alkane. Is it clear? How to draw the isomers of alkenes. So example, if I say I have pentene. So if I want to draw isomer of pentene, what I can do, first I can change the position of double bond. So if I change the position of the bond, so 1, 2, 3, 4, 5. So the double bond with the first two, 1 and 2, I will make between 2 and 3. So this will be CH2, CH, CH, CH2, CH3. So this will be pentoene. And I can draw a cyclic alkane, not alkene, even though it will have a single bond, but this is also an isomer. The definition of isomer means that they should have same molecular formula. So when I write the molecular formula of this compound, like this is CH2, 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 and CH2. So when I write molecular formula, it is C5, H10. When I write molecular formula, this is also C5H10. When I write molecular formula of the first one question, it is C5 and H10. So these compounds, they have the same molecular formula, but different structures. That's why we call them as isomers. You can also make a branch, but when you make a branch, it will become difficult for you to name. That's why to make a simple isomer, just change the position of double bond or draw a cyclic alkane. As a homework, I want everyone to write the uses of alkenes, at least 3 uses of alkenes, 3 journal uses, like not any specific alkene, journal uses of alkenes. Next is alcohol. Alcohol means it contains OH. The name should end at OL. And the journal formula of alcohol is CN H2N plus 1 OH. That's a journal formula for finding alcohol. Like example, if I say what is the formula for propanol? So the formula for propanol, prop means value of N is equals to 3. So substitute value of N is equals to 3. So C3H2 multiplied by 3 plus 1. So 2 multiplied by 3 is 6 plus 1, make it 7. And then OH. And when you further solve it, it will become C3H7OH. So that is the formula for propanol. What is the formula for butanol? Where N is equals to 3. What will be the formula for butanol if you substitute N is equals to 3? So it will be C4H9OH. What is the formula for methanol? Meth means N is equals to 1. CH3OH. And what is the formula for hexanol? Hex means the value of N is equals to 6. So C6H12 multiplied by 6 multiplied by 2, 12 plus 1, 13. So C6H13OH. So these are the molecular formula of these compounds. So using a journal formula like in alkanes, alkene, and now in alcohol, we can use this formula to work out the type of alcohol. Then naming alcohols, we did this part. I will quickly go through. If OH is attached, you have to number the carbon atom. OH is attached with the second carbon. What is the name of this compound? Four carbon atoms. OH is attached with the second carbon. The position of OH is also important. But because of 4 carbon, that's correct. And because they have a single bond, but we'll not write A and E because the functional group is starting with a vowel. So it is butan 2 all. But because of 4 carbon and because of single bond and 2 There are 4 carbon atoms. This we already discussed. There are 4 carbon atoms. We number the carbon atoms. If I number from right hand side 1, 2, 3, 4. So third carbon is having OH. If I number from left hand side 1, 2, 3, 4. Second carbon is having OH. So we always follow a numbering where the OH is closer. So second position we have OH. That's why it is butane 2-ol. What is the name of this compound? Propane 2-ol. Why 2-ol? Because OH is attached with the second carbon. So the position of OH is also important. If OH is attached with the first carbon, then propane 1-ol or propanol. Formation of alcohol. How we can form alcohol? There are 2 ways to form these alcohol. One is known as hydration of alkene. Hydration, the term hydration means addition of water or steam. And the other one is fermentation. Fermentation of the glucose. So if we want to prepare, like example, the term hydration, like what happened in hydration, what are the reaction conditions for hydration, and what are the reaction conditions for fermentation. So first what we do, like preparation for fermentation, we use glucose, now what are the reaction condition, at what condition the glucose or a sugar solution will turn into alcohol such as ethanol. So temperature is about 30 degrees centigrade in anaerobic conditions. You have to remember these reaction conditions. Temperature is about 30 degrees centigrade, a room temperature, and but not too high. Anaerobic conditions. Anaerobic condition means no oxygen should be there. For anaerobic respiration, you studied in biology. So no oxygen, and we use yeast which contain enzymes. And what are enzymes? Enzymes are biological catalysts. And the biological catalysts are not effective at all the temperature. At certain temperature, they are working efficiently. If the temperature is too high, then it will denature the enzymes. And what happens in fermentation when we have a glucose, the word equation, in the absence of oxygen, basically this glucose will decompose into ethanol and carbon dioxide. but the condition for hydration, the temperature, it's around 300 degrees centigrade. We use 60 to 70 atmospheric pressure. And we use phosphoric acid as a catalyst. Phosphoric acid is not a biological catalyst, so it will have a catalytical activity even at higher temperature. And the journal equation, if we want to prepare ethanol, so journal equation is alkene plus steam will give alcohol. But if we want to prepare ethanol, so ethene plus steam, this will result in a formation of ethanol. So we have only one product formed here. But these two methods, there are some advantages of using the method and there are some disadvantages when we prepare alcohol by these methods. A hydration of alkene, condition 300 degrees centigrade to 60 to 70 atmospheric pressure, and phosphoric acid as a catalyst. Fermentation of a glucose around 30-degree anaerobic condition means no oxygen should be there, and yeast which contain, we use a yeast which is having enzymes which catalyze the reaction, but the temperature should not increase. Why? If the temperature increase too much, it will denature the enzyme and the reaction will slow down or eventually it will be stopped. So there are some advantages and some disadvantages for manufacturing ethanol by these methods. First, for advantages of manufacturing ethanol by fermentation. So what could be the advantages when we compare, when we are the process for manufacturing ethanol? So you can see it is using a low temperature So the advantage of using a low temperature is that it will be inexpensive, like it will not cost too much. So advantage of manufacturing ethanol by this method, it is inexpensive and it is using the raw material, like example a glucose. So glucose is a renewable raw material, means every time, like you can extract this glucose, you can, the plants will grow and you can take out this glucose. So it is using a renewable raw materials. And small amount of energy is needed because it is done at room temperature, so a small amount of energy is required to carry out this reaction. But what are the disadvantages when you compare? So the reaction does not last for a longer period of a time. It is a slow process. Like this method will take very long time, slow process. Uh, Impure product is there. Why impure product? Because you can see when glucose is forming ethanol, carbon dioxide gas will escape, but still not all of the glucose will convert into ethanol, because when alcohol is formed, the yeast is killed off. That's why you will not have 100% ethanol. So it will result in a formation of impure product, or the product you have to purify. But what are the advantages of manufacturing ethanol by this method, hydration of alkene? So if you want to manufacture ethanol by this method, it will be a fast process and it will give you a pure product. But the disadvantage that it will increase the cost, required a very high temperature, so expensive, and increases the cost to maintain a high pressure. So first, the advantage is a fast process and it will give a pure product, the only product or greater yield. So we don't have to purify ethanol, only ethanol is formed, so we can obtain that. But disadvantage, it is expensive and non-renewable raw materials. Because these raw materials, from where we get ethene is by basically from, first we do a fraction distillation of the crude oil, we obtain different large fractions, then we do a cracking, and cracking produce ethene. So basically this is from the crude oil. So it is a non-renewable source that a time will come when we'll run out of this crude oil, so we'll not be able to carry out this process. And this required lot of energy to carry out the process. Is it clear? The formation of alcohol. So there are two ways by which we can form alcohol. One is by hydration, another one is by fermentation. Then the reactions of alcohol. The reaction of alcohol, there are two reactions of alcohol. One is combustion, another one is oxidation. So alcohol, when we burn alcohol, so alcohol plus oxygen, in the presence of a spark or a flame, when it burned, it released carbon dioxide plus water. Then alcohol plus oxygen, because the term oxidation means addition of oxygen. This will result in a formation of carboxylic acid plus water. So what is the difference between the combustion and the oxidation? And here in oxidation, we use an oxidizing agent. An oxidizing agent is used for this reaction, which is potassium manganate 7 or potassium dichromate 6. I will write the names as well. But what is the difference between oxidation and combustion? Basically, look what you have. So you have a container which is filled with alcohol. So you add, like, if nearby oxygen is present in the atmosphere, this is alcohol. But what we did, in the presence of a fire or a spark, like a small spark, you produce a spark, and that spark cause a violent reaction between alcohol and oxygen, and this result in a formation of carbon dioxide and water. This is called combustion, like burning. But what is oxidation? The term oxidation means addition of oxygen. So without or this presence of this spark or a flame or fire, naked flame or fire, we have alcohol, and nearby oxygen is there. And what we do, we add an oxidizing agent to speed up this reaction. Oxidizing agent means help in oxidation or help in addition of oxygen to make it reaction easy at room temperature. So this addition of oxygen to alcohol result in a formation of carboxylic acid. So there is a small difference here. Both are addition of oxygen. Even combustion is also oxidation reaction, because that is addition of oxygen. But specifically combustion, when you burn something, you have a flame or a fire, you use the term oxidation. You use the term combustion. But without a fire, if oxygen is added, we call simply that as oxidation. Is it clear? The difference between the two reactions? The difference between oxidation and combustion here. Combustion means burning, oxidation means addition of oxygen. And the oxidizing agents which we use here, we use potassium dichromate, two oxidizing agents use. If you use potassium manganate 7, it will change from purple to colorless. And if you use potassium dichromate, that is not 4, it's potassium dichromate 6 is there. So it will turn from orange to green. So we will continue this reactions of alcohol next class. So these are the two reactions equations. Also, I will write the equation. And next week, likely we will complete this organic chemistry. Any question related to the class? This reactions of alcohol, I will continue in the next session.